What happens when your API hits 1800 requests per second and suddenly crashes to 600? In our last episode, we discovered our catalog API's breaking point with K6. Today we're adding Prometheus and Grafana to get X-ray vision into exactly why system fail and where we find the bottlenecks. Quick recap from episode 6. We used K6 closed model testing to find if our API could handle about 100 virtual users before the threshold of the response time was met. But we were essentially flying blind. We could see the symptoms, but not the cause. Today, that changes. We are integrating K6 with Prometheus and Grafana to transform our performance testing from reactive to diagnostic. Complete data flow. K6 is not just running tests. It's streaming metrics in real time to Prometheus. K6 pushes load testing metrics directly to Prometheus via OTLP, so the OpenTelemetry protocol, while our APIs send their system metrics like CPU, memory, and database connections also via OTLP to the same Prometheus instance. This means Grafana can correlate between streams simultaneously. When K6 shows 200 virtual users generating 1800 requests per second, we can see in real time how this translates to how many CPU utilization on our PostgreSQL database. Before we dive into results, let me walk you through the K6 test. First, notice our test configuration. We are starting a stage ramping pattern, starting from 0 to 50 through 100, 200, 400, and 600 virtual users. Each stage maintains its target for 60 seconds, giving us stable measurement windows. We have set a 95 percentile response time threshold at 500 milliseconds and an error rate threshold at 0.01%. Our test isn't just generating load, it's also validating responses. Every request checks for HTTP 200 status, validates response time under 500 milliseconds, and ensures that JSON response contains valid catalog data. This gives us both load generation and functional validation in the same time. Each virtual user is trying to send as many requests as possible, so we are starting from 235 requests per second, even though that we have only 12 virtual users. So then we quickly ramp up to the maximum request from the client side, and then we hit some plateau, as we can see in here. Then we go to 1800, and then something happens. So then we goes down to 600, and then we see a straight line about 700 requests per second. So this is interesting situation. So correlating this with the virtual users, as we see, we hit when we hit 50 virtual users, we hit this first plateau, and then we go to 100, and this is that, and we then raise from 100 virtual users to 200. So when we add to 200, we see significant drop of requests per request rate, and we see significant drop. And why does it happen? It happens because the performance of the API slows down. And also we can see that when we hit this point of 100 users and more, we see a significant raise of the response times. And we see from 100 milliseconds to 200 milliseconds or more, and then up and up. And then we hit our threshold of 500 milliseconds for percentile of 95. We hit 498 when we hit about 300. Also correlating the response time between K6 load testing, how it looked from the client perspective, with how it looked on the server's perspective, we can see that 500 milliseconds, it's here, 27. It's almost the same point. So we can see that it matches for that same percentile. This is the superficial analysis of the client side, what happens on the K6 from the K6 perspective. But what happens on the on the system level. So we can see for the CPU, for the catalog API, we can see quickly that it raises from 0% to 71%, 98% very, very quickly. So it cannot hold any more requests. And when it happens when we have 24 virtual users. So pretty quickly. And we see that we maintain 100% CPU utilization all the time. Then we drop to 56. And then something happens, and then we maintain this. We maintain it on 58%. So it looks like something is blocking us from this moment. So from this 1224, that we are actually going down. Instead of we raised, we were on a 600 requests per second, and then we dropped from 1800 to 600, to 1/3 of that. And it wasn't CPU of the catalog API. So what happened actually? That it slowed down, right? We need to take a look. What else can we say about this system? That memory looks stable and it's not a problem with that. Also take a look on the throughput. We can see that we reached about 1300 requests per second for catalog API. And that was our maximum throughput of the system that it could digest. Yeah, so what about this problem that we raised from 100 and then we went to 56 CPU, even though we were adding up more and more requests? Maybe let's correlate the CPU and API throughput, right? We can see that the throughput in here this is 100, and then we actually consumed a little bit more. So maybe this is a coincidence. So I don't see this correlation between those. It has to be something different. The thread pool utilization looks good. Garbage collection performance looks good. HTTP request activity looks good to me. And we hit the problematic part. So it explains perfectly why it happens like that. When we hit 1800 requests per second, we hit this point. Take a look. We hit this point of 100% of the CPU utilization for Postgres CPU utilization. So we hit here the database maximum capacity, and then we maintain 100% CPU utilization all the time. So it is an actual blocker to us. Also, we can see here, this is the pool utilization, the database pool utilization, and we were maintaining from 85% to 38%, and we were going back and forth with that. Then we started to hit the ceiling with the pool utilization. So it means take more connections from other parties. And we see here also that we maintain 100%. So it perfectly explains why when we hit this point, it can no longer take more requests. So it means that PostgreSQL is our bottleneck. It means when we hit this point, it is 100%, and it's going to towards 100% of the max CPU utilization, and it's restricting us from performing faster and faster. So that's why we hit this plateau. And this is actually a very good example of something called back pressure. Think of it like a traffic. Our catalog API is a 4-lane highway capable of handling 1800 requests per second, but it feeds into a single lane bridge. It means our PostgreSQL database. So once that bridge reaches 100% capacity, traffic bucks up through the entire system. And no matter how fast our API is, we are constrained by the database bottleneck. So thank you. That's all from me today. Subscribe for episode 8, where we'll solve this PostgreSQL bottleneck and push past 1800 RPS. See you next time.